Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 23, True and False Number Senses. Opening exercise says to determine what each symbol stands for and provide an example. So this symbol here means is equal to. So I could say 1.25 is equal to 1 1/4. The symbol here, it means is greater than. 5 is greater than 0. This symbol here is less than. An example would be 3 is less than 10. Okay. This symbol here is less than or equal to. So an example could be 3 is less than or equal to 4, which is true, or 3 is less than or equal to 3. So this is true as well because of that equal sign. 3 equals 3, that's true. 3 is less than 4, this one's true. Okay, the last one is greater than or equal to. So I could say 3 is greater than or equal to 1. That's true because it's greater. Or 3 is greater than or equal to 3. Okay, now let's talk about greater than or equal to and less than or equal to again. If these symbols, if you can't remember which is which, it's easy to determine which direction they go when you're given two numbers. So everybody knows that 5 is greater than 0, and when I was growing up and learning math in elementary school, I remember the teacher saying, this is the alligator's mouth and it eats the bigger number. Okay, that's all good unless you don't have numbers on both sides. So if I had this, okay, we don't know what x is, so I can't use that trick to determine if that's greater than or less than. So I need to know another way to remember that. So I tell my students to draw a line coming out of the center of this and this one, and it looks like a number line. So as I'm going to the left, if this was 0, this is -1, this is -2, then my numbers are getting smaller, so that has to be less than. And again, if I did the same over here and put a 0 here, this is 1 and this is 2, and the arrow is my number line direction pointer, and it's telling me to go to the right, which means that the numbers are getting bigger, so that would be greater than. Okay, so that's helpful if you have a variable involved in your inequality. So you can't use the alligator trick. Okay, example 1. For each equation or inequality that I will display, write the equation or the inequality and then substitute 3 for every x to determine if the equation or inequality results in a true number sense or a false number sense. Okay, so here are the 3 that I'm going to display. So what it's asking us to do is, put this up a little bit, it says for each equation or inequality that I display, so I displayed 3 of them, write the equation or inequality, and then so you're supposed to copy these down. So copy these down, pause the video, substitute in 3 for every x, put a 3 here, put a 3 here, put a 3 here, and determine if it's the inequality or the equation is true or false. Okay, so try that, and we'll come back and see. Okay, so here we go. So if I substitute in 3 for x, 5 plus x, 5 plus 3 equals 8. Simplify, 5 plus 3 is 8. 8 equals 8, that is true. Now I have a 5 times x equals 8, so I'm going to write 5 times 3, replacing that x with 3, equals 8. 5 times 3 is 15. 15 equals 8 is false. Plug in 3 here. 5 plus 3 is greater than 8. 5 plus 3 is 8. 8 is greater than 8. That is also false. Okay. Now the exercise says to substitute in the indicated value into the variable, state in a complete sentence whether the resulting number sentence is true or false. If true, find the value that would result in a false number sentence. If false, find the value that would result in the true number sentence. Okay, so pause the video, see if you can do these 6, and then come back and we'll see how to get there. Okay, so we can always guess and check, but we're preparing for algebra in this class, so what we want to do is solve this algebraically, and in one step we can find the number that would make that true. Okay, so this says to substitute 8 in for x. So if I say 4 plus 8 equals 12, and I add 4 and 8, it gives me 12, and 12 does equal 12, so that is true. So it said in a complete sentence if it's true. So what I would say is when 8 is substituted in for x, the number sentence is true. Okay, so there's my complete sentence. But now it says, if true, which it is, find the value that would result in a false number sentence. Okay, well 8 is the only number that will make this true. So I am going to choose any number. This answers will vary. So if you had 4 plus 9 equals 12, 13 does not equal 12, that is false, and we always draw a line at an angle through an equal sign. That means 13 is not equal to 12. Okay, so continuing on to number 2. Substitute in 3 parentheses, 4 and 1/2 is greater than 15. Okay, 3 times 1/2 is 3 and 1/2, so I'm going to put a 1/2 there, and I'm going to carry over the 3. 4 times 3 is 12. 12 plus 3 is 15. So 3 times 4 and 1/2 is 15 and 1/2. 15 and 1/2 is greater than 15, so that is true. Okay, that is not true. My fault. I multiplied wrong. 3 times 1/2 is 1.5. I said 3.5. It's early. Okay, so 3 times 1/2 is 1 and 1/2. 4 times 3 is 12, plus that 1 is 13. 13 is not greater than 15. That is false. Okay, so it says, if false, find the value that would result in a true number sentence. Okay, so now I have 3g is greater than 15. Now, when I'm talking about algebra, now we have to find a value that would make that true. I can divide by 3 on both sides and get g, because these cancel, is greater than 15 divided by 3, which is 5. So I need a number greater than 5 to make this true. 5, it does not make it true, because 15 is not greater than 15. So any number greater than 5. So my example would be g is greater than, or g, when g equals 6, I should say. So when g equals 6, comma, 3 times g is greater than 15, because 3 times 6 is greater than 15. 18 is greater than 15. Okay? Alright, next question. F over 4 is less than 2. Substitute 8 for f. So I'm going to write 8 over 4 is less than 2. Well, 8 divided by 4 is 2. 2 is not less than 2, so that is false. So I need a number to make this true. So I need a number that is going to make this true. So if I take f over 4 is less than 2, and I want to get f by itself, I multiply both sides by 4 over 1. And these 4's cancel, and I get f over 1, which is f, is less than 2 times 4, which is 8. So I need a number less than 8. So when f equals 7, this will be true. I'll show you by saying 7 over 4 is less than 2. 4 goes into 7 one time, so the remainder of 3. 1 3/4 is definitely less than 2. Okay, number 4. I'm going to substitute in 25.8. So I say 14.2 is less than or equal to 25.8 minus 10.3. 14.2 is less than or equal to 8 minus 3 is 5. 5 minus 0 is 5. 2 minus 1 is 1. 14.2 is less than or equal to 15.5. That is a true statement. My sentence is when 25.8 is substituted for h, the number sentence is true. Now I have to find something that makes it false. So I'm going to write the formula, or the inequality. And I want to get h by itself, so I'm going to add 10.3 to both sides. And when I do that, this goes away, and I get h has to be greater than, and when I subtract, I get 3.9. So h has to be less than 3.9. So to make this false, I'll pick a value greater than 3.9. Let's see. Oh, I'm sorry. I didn't add. I'm out. Add 10.3, not subtract. I subtracted. So I get h is less than or equal to 5, 4, 2. Okay? So I'm supposed to add, not subtract. So if I add 10.3 to both sides, I get 24.5. So any number, the number has to be less than 24.5. So any number less than 24.5 will make this true. So let's choose 20. So if I say 14.2 is less than or equal to 20, which is my h, minus 10.3, and I take 14.2, 20 minus 10.3 is 9.7. 14.2 is not less than 9.7. This is false. Okay? Number 5. Substituting 6 for h. 4 equals 8 over 6. 4 equals 4/3, or 4 equals 1 1/3. That is false. A complete sentence is when 6 is substituted in for h, the number sentence is false. I want to know when this number sentence is true, so I'm going to write 4 equals 8 over h. Okay, so in order to get rid of this, I want to get rid of this fraction. There is a shortcut. I will not show you that. I'm just going to get that h out from underneath, and when I do that, I get 4h equals 8. And then when I divide by 4, I get h equals 8 divided by 4, or h equals 2. This is the only value that would make this statement true. Okay, and number 6. 3 is greater than k plus 1/4. Substitute 1 1/2 in for k. So now I have 3 is greater than 1 1/2 plus 1/4. So 3 is greater than 1 1/2 plus 1/4 is 1 3/4. That is true. So my number sentence will be when 1 1/2 is substituted in for k, the number sentence is true. Now I have to find when this is false. So I'm going to solve this for k. So I write 3 is greater than k plus 1/4. To get k by itself, I subtract 1/4 from both sides. 1/4 minus 1/4 is 0, leaving me with k. 3 minus 1/4 is 2 1/4. So 2 1/4 is greater than k. If I flip that around and put the variable first, it's more understandable. Okay, so I just flip this around. So now k is less than 2 1/4. So now if I plug in 2, because 2 is less than 2 1/4, and I say 3 is greater than 2 plus 1/4. 3 is greater than 2 and 1/4. That is true. So any number less than 2 1/4 would work. 2, 1, 0, -1, -2 to infinity. Negative. All right. And now we have 4 more. So I'm going to just do these quickly. I'm not going to worry about this sentence anymore, but you should still keep doing the sentence. I just don't want to take time in the video to say the sentence every time. So I'm going to substitute in 2.5. So 4.5 minus 2.5 is greater than 2.5. 4.5 minus 2.5 is 2. 2 is not greater than 2.5. So that is false. I have to find a value that makes it true. So I take 4.5 minus d is greater than 2.5. And I get d by itself by subtracting 4.5 from both sides. Actually, I'm going to do something differently here. Now I'll do that. Minus 4.5 from both sides. And I get, don't forget, this symbol here does not go away. I get negative d is greater than 5 minus 5 is 0. 2 minus 4 is -2. If I multiply this whole thing by -1, I get d, and I get 2 over here. And then when I multiply by a negative, the inequality flips. So to make this statement true, I have to pick a value less than 2. So how about 0? 4.5 minus 0 is greater than 2.5. 4.5 is greater than 2.5. That is true. Okay, substitute in 1/2. 8 is greater than or equal to 32 times 1/2. 8 is greater than or equal to half of 32 is 16. That is false. 16 is not greater than or equal to 8. Or it is. 8 is not greater than or equal to 16, I meant to say. And now I need to find a value that makes that true. So 8 is greater than or equal to 32p. I have to divide by 32 to get rid of this multiplication. So if I divide this by 32, these cancel, and I get 1/4. If I flip that around, okay, flip my sign, change everything, flip everything around, p has to be less than 1/4 to make this true. So if I choose 0, 32 times 0 is 0, 8 is greater than or equal to 0, that is true. If I plugged in 1/4, I would get 8 is greater than or equal to 8. That is also true. Okay, so any number less than or equal to, forgot my equal sign, p is less than or equal to 1/4. Okay, number 9. Substitute in 16 for w. Simplify. 16 divided by 2 is 8. That is a true statement. 8 is definitely less than 32. So let's find a false statement. I want to solve for w. This is division. The inverse of division is multiplication. So I'm going to multiply both sides by 2. These 2's cancel. And I get w is less than 64. So to make this statement false, I have to pick a number greater than 64. So if I pick an even number greater than 64, such as 66, and I rewrite this as 66 instead of w, 66 divided by 2 is less than 32. 66 divided by 2 is 33. 33 is not less than 32. Number 10. Substitute 14 in for b. I get 18 less than or equal to 32 minus 14. Do the calculation. 32 minus 14 is 18. 18 is less than or equal to 18. That is a true statement. It is equal. To make the statement false, we have to solve for the variable. In order to get b by itself, I have to get 32 over to the other side. When I do that, 18 minus 32 is -14. Is less than or equal to, don't forget this negative sign, negative b. I don't want a negative variable, so I'm going to multiply the whole thing by -1. -1 times -14 is +14. -1 multiplying an inequality flips it. -1 times a negative b is positive. So I need a value greater than 14 to make it true. So to make this false, I want to pick a number less than 14. So I will choose 13. Check. 18 is less than or equal to 32 minus 13. 18 is less than or equal to 32 minus 13 is 19. I'm sorry. 32. What number was I picking? 13. 18 is an 8. 18 is less than or equal to 32 minus 10 is 22. 19 is 19. That is still true. All right. Okay. I wasn't thinking of this properly. When b is greater than 14, that'll be true. I've got to pick a value less than 14. So what I forgot to do was I need to rearrange this so that the variable comes first. So if I put b here and I put 14 here, I have to flip this sign. So this is true whenever b is less than 14. I need to pick a number greater than 14 to make it false. 15 is not greater than 14, so I will choose 15. Okay, now we've got this straight. 18 is less than or equal to 32 minus 15 is 22, 21, 20, 19, 18, 17. 32 minus 15 is 17. 18 is not less than or equal to 17. That is now false. So any number greater than 14 will make that false. Okay, that is the end of lesson 23. Go do your problem set.